Assalamualaikum warahmatullahi wabarakatuh, and hi again. In this video, I'm going to discuss with you about no gate latch. For the no gate latch, we have two of the no gate here, which is corresponding to each other, and the truth table or the function table of the no gate is like this, where when the state of the set and reset is both 0, they have no change, and when the set is 1, reset 0, Q will be this one, this Q output will be 1, and when the set is 0, reset is 1, the Q here will be 0, and when both is 1, 1, it will be invalid. By default, the system will force you to produce the 0. For the no-SR latch is a stable condition when our both inputs is low. But now we're going to change that the state where we want to set our Q here. So how to set this Q? What is mean of set? So set means that we change this Q to the height or 1. To change this Q to 1, we need to give a height input for the S. So now you can see that the Q bar becomes 0 and this Q become 1. Now we already able to set our latch. Okay, so how we get this as a 1? So if you look here, that here during this condition just now is a 1, and here also, and our output here will become 0, and this 0 will be go here and it becomes 0. And if we look at the no here through table, we can see that when the input is about 0, 0, the output is 1. So we're going to get our output here as a 1. Okay. So also here, this one will go to here as a 1, 1. So we can see from this here, this 1, 1, we get a 0. So it's comply with the no gate condition here. Next, we're going to reset our Q. So what is reset? Resets mean that we want to make our Q here as a 0 or low condition. So now how to reset? So in order to reset our Q or our latch here, we need to give high signal to the R input. So if you look here, when we give a high, and now our Q will be turned to 0 and Q bar will be turned to 1. So how this is happen? Again, this 1 input of the 1 here come to here. So when we apply 1, 1, so the output will be 0, and this input will be, so we will get a 0, 0. So when both is a 0, according to our truth table, we get the 1. So this is how we get the output in order to set and reset our latch. We also can give equivalent representations to our non-latch gates, which is it can be represent like this one by using AND gate, and we have a bubble or inverter here. So again, how we get this circuit is by using by apply De Morgan theorem. Okay, now let's look example for the waveform of our no latch gate. So let's say we have the initial condition for our Q is 0. So our initial condition is a 0, and now we're going to have a input of the set and reset like this signal. And what is the signal for the output Q here? So we're going to look one by one. So now, since our set is a 0 and our reset is 0, so at this moment there's no change. And remember, this is a 0 because our initial condition is a 0. But if our condition is 1, so it will be 1 here remain. Okay, so this is a 0, and then we look here, set is 1, 0, 1, 0, Q will be 1, and next here 0 0 0 0, no change, so it's maintained as high. And here we have 0 1 0 1, so our Q will be 0, right? Will be 0. And now 0 0, no change, 0 0, no change, and 0 1 0 0 0, no change. At here 1 0 1 0, now it's changed the stage to the 1, and here is 0 0, meaning no change. So all this will be no change until we get another pulse here. Okay, so that's how we draw the output for the Q waveform.